This is a 3-channel power supply, and we'll be using it for our digital circuits. It has an on and off switch for the output, and it's current limited, which means that you can set the maximum current for the circuit. And if there's a problem with the circuit, it'll display the letters CC, constant current, instead of CV for constant voltage. So always keep an eye on that, and that's always to the left of the current display. We're going to start off by setting the supply voltage to 5 volts by pressing VSET, and then you can use cursors or the rotary dial to set it to exactly 5.0 volts. After setting the voltage, you want to set the current limiting by pressing I-set. And you can do that with the dial or with the keypad, so you can type in a value. And I believe in this example, I'm going to set it for 250 milliamps or 0.25 amps. And I've typed it in directly on the keypad and then hit enter. Eventually it'll stop flashing and it'll show you the current output. So I want to turn the output on. So it's showing me that I have a voltage of 5 volts. And my current limiting is set to 250, but it's drawing 126 milliamps right now. And I believe I'm going to simulate a short circuit by shorting the alligator clips, and that gives me a constant current of 250 milliamps. The next piece of equipment we'll look at is a generator. And this function generator produces digital signals and sine wave signals. And we're going to be using it this semester to create signals to apply to our digital input circuits. And you can adjust the amplitude, the DC offset, and the frequency, and the signal type. In our case, we're almost always going to be using a square wave. And we want to set it typically to 5 volts peak to peak and a DC offset of 2.5 volts. After turning on the supply, we want to go to a default setup. And to do that, we want to press this utility button and then system. And you can see there's something that says power on, and it can be default or last. And I'm switching it over to last. And that will always bring up the last setting that we had. Okay, and once we've done that, I'm going to turn off the power. So this is the default setup: 1 kilohertz, 1 volt peak to peak, 0 millivolt offset, and sine wave. I start my configuration by pressing the square wave button. And then the next thing I want to do is make sure I leave the output off until everything is configured. But my next step will be to set the amplitude. For digital circuits, we want to have an amplitude of 5 volts peak to peak. So here I'm typing it in the keypad, and once I've done it, I hit peak to peak. Okay, and you can see on the display it's going from minus 2.5 to plus 2.5. So I have to change the offset to give it a 2.5 volt offset. So enter 2.5 and then press the volts button. After all settings have been configured, press the on-off button so that the output actually appears on that connector. Another optional setting can be found under Utility and the System button. Here we're going to make a change, and it'll be on the power on setup. Instead of being default, we're going to change it to the last. That way, when you turn the power off and back on, it'll hold whatever settings were last configured. Another optional setting is to go to Default Setup and change the output load resistance from 50 ohms to high impedance. And for most situations in the lab, this is what you should be using. And that's because the oscilloscope that we're connecting to also has a high input impedance. Once you've done that, press the back button and you'll see it brings back to a default setting. For digital signals, select the square wave type. The next step is to select the amplitude. So press this button. And you can do it in two ways. You can use the keypad or you can use the cursors and the dial. So here I've set it to 5 volts peak to peak. The next step is to adjust the offset. So press this button. And again, you can use the dial or the keypad. I'm going to enter 2.5 through the keypad. Once you're done, press V for volts, and that sets up the offset. The next step is to turn the output on. Here I'm using the scope just to verify that the output is as expected, and it is. Besides setting the amplitude, offset, and signal type, we can also change the frequency by pressing the frequency button. And you can also switch between period and frequency, and I can change either one of those. Very simple to do. The next piece of equipment we'll be using is the oscilloscope. And at least for now, there's only 3 settings that you have to set up on the oscilloscope. And that's the vertical scale, and we want to use 2 volts per division. Then we'll be setting the horizontal scale, which is going to be set for 500 microseconds per division. And then we also want to make sure that the trigger level is at the 50% point. To erase all previous settings and start fresh, press the preset button. After pressing preset, then we want to adjust the volts per division. Turn it counterclockwise until we have 2 volts per division. The next step is to adjust the time base to 500 microseconds per division, and there we have it. After setting the vertical and the horizontal, I want to trigger the signal, and a simple way is to press this trigger level button to set it to 50%. There is also a menu to set other trigger settings, so press the trigger button. And right now it's triggered on a rising edge, but I can change it so that it triggers on a falling edge, which I've just done. Press the measure button, and this brings up this menu. And the measurement menu allows you to make various measurements at different points near the bottom of the screen trace. And so the first one I'm going to do is to make a measurement of the period of the signal, frequency of the signal, and it appears near the bottom left. And then I go back to that menu and select a second position, number 2. And at number 2, I'm going to set it up to measure period. So press that, select period. Okay, and the second measurement is measuring the period. And then finally, the third measurement I want to make is the duty cycle. So I'm going to press the third position. And this time it's not one of the basic menus, so I actually have to go to horizontal. So there's a button for that. And then this gives me many different measurements, and I want to measure the positive duty cycle of the signal, which is right here. And that's the third measurement. The last piece of equipment that we have access to in the lab is the digital multimeter. This is a very important device because it can measure AC volts, DC volts, resistance, capacitance, and check diodes and LEDs. So as you can see, the first measurement I'm making is measuring the current, and you have to make sure that button is pressed, and you also have to make sure that the black lead is in the center and the red lead is down at the bottom when making current measurements. To make a voltage measurement, make sure that green button is turned on, and it just measures the volts in DC. Here I'm doing a simple diode check, and I have the black lead connected to the cathode and the red lead connected to the anode, and it's measuring about 0.6 volts when it's forward biased. This is a test of a non-working LED, and I have the red lead connected to the anode, black lead to the cathode. This is a test of a green LED that does work, and it's reading a forward voltage of about 2.34 volts. This is a red LED, and it's reading about 1.8 volts forward biased. This is the forward bias voltage for a yellow LED. The digital multimeter can also measure capacitors, both electrolytic and non-electrolytic capacitors. I've switched the meter to measure capacitors, and this one is supposed to be a 0.22 microfarad capacitor. And it's not polarized, but I did short the leads just before making the measurement and showing about 0.22. Now I'm testing out an electrolytic capacitor, which is supposed to be 47 microfarads, but this device is reading it as 53 microfarads. That's very common for these capacitors. They have a wide tolerance range. You can see that 47 microfarads is written on it. I will actually add a capacitor sheet. The meter can also measure resistors, and here I have a 1K resistor, and you'll notice it's not exactly 1K in the meter because it's plus or minus 5% tolerance. And then I'm going to switch over to a very low resistance value, 39 ohms, and let's have a look at what the meter is showing us. 39 ohms.